Hi everyone. I got some anonymous feedback asking for some tips about coming up with and working with loop invariants. So that's what this video is about. So first of all, the most important thing to keep in mind is that loop invariants are a formalization of your intuition. Most of you are very good at figuring out what the code does, or like how the loop works. This is an intuitive process for most of you, a skill that you developed in 108 and 148. The key thing about what we're doing in this course is not we're trying to get rid of your intuition altogether. It's that we're trying to give your intuition some extra structure. So whatever your intuition is about what the code does, you should try to incorporate that in your loop invariant. Also, keep in mind that loop invariants are incremental. They don't say what's true when the loop ends. They say something that's true every time the loop runs, at every iteration. And so because of that, we often have invariants which deal with the part of the list that's been processed so far. Maybe this is a slice like a from 0 to I minus 1. Or, on the most recent challenge, a from j to I. And when you're dealing with numbers, they usually talk about some mathematical relationship or size bound between the numbers. So a bad loop invariant would be x is equal to 0. Because yes, maybe x is equal to 0 when the loop ends, but if x is changing within the loop, then it's definitely not always equal to 0. Here's an important idea that I talked about in class, but I'll mention again. Loop invariants have no concept of time. They can't tell you what happens in the code in the loop or before the loop or after the loop. They can't tell you anything about what the code is going to do next or what it's done before. They can't even tell you how many times the loop has run. What loop invariants can tell you is at one particular moment in time, usually when the loop condition is checked, this statement about the variables is true. And we have no idea what's going to happen next, or what's happened before. And here's another common mistake that I'll mention again. Don't confuse loop invariants with the loop condition. The loop condition has to be true every time the loop runs, but the loop invariant is true even when the loop condition is false, and so the loop exits. This is why even when we have loop conditions like x is greater than 0, our loop invariant might still be only something like x is greater than or equal to 0. Because when the loop exits, we can use the fact that x is greater than or equal to 0 plus the fact that x is not greater than 0 to conclude that we know the exact value of x. X is equal to 0. And this brings me to my final point about really reasoning with loop invariants, whether you're proving that a loop invariant is correct or you're showing that it's useful by using the loop invariant to prove the postcondition. In your proofs, the only facts which you should be using are invariants, the loop condition being true if you're inside the loop, the preconditions, and math. Anything else that's coming from your intuition, that should be part of an invariant. A lot of you made this mistake on question 2 of the second midterm. For 2a, you created a loop invariant for count, which was not very helpful. Something like count is less than or equal to the length of a. But then in part b, when you wanted to prove that the program is correct, all of a sudden, you said something like, well, we know that when the loop terminates, count is equal to the number of times aj was greater than a0 for j between 0 and the length of the list. And the funny thing is, this is what your intuition told you about what the code does. And this was correct intuition. All you needed to do in this question was formalize that intuition into a loop invariant. So I hope this video helps. If you have any questions about loop invariants in general, come see me during office hours or post a question on Piazza or post a comment for this video. Thanks, and have a great day.